Just as a recap, we kind of talked about why we would potentially use Kubernetes, what the tooling on top of Kubernetes looks like. We deployed Kubeflow. That was the last thing that we were talking about. We were gradually working our way through this stack. Here, and we had got to Kubeflow deployed. So remember, Kubeflow, it contains all of these nice definitions and packages and that sort of thing that we're going to be utilizing for the rest of the pipeline. But we still need to actually deploy these particular pipelining and serving elements that we need to use. So we need to deploy Selden and we need to deploy Pachyderm. So that's what we're going to do next. If you haven't, go ahead and log back into your instance. And actually, let's just check. You should be able to run this kube control command to see the services that are running, which should include some things for Kubeflow. And sorry, was there a question? Oh, the password for the machine is right here. As a reminder. Okay. So we have Kubeflow deployed. Now let's deploy Selden and Pachyderm. As you'll notice, there's kind of a theme going on here. So we deployed Kubeflow, which was, I don't know, not terrible, maybe a little annoying. But then after that, we kind of repeat a similar pattern to deploy the various things on top of that. And instead of having to go through specific config and manifest and everything for these individual pieces for like pipelining and serving, all of that's included pretty easily with Kubeflow. So let's go ahead and generate a template for Selden, which we can do this way. Again, oops. Oh, sorry. You should be here, right? Under your KSonnet application. So you should be under pacrat my Kubeflow. Now we should be able to run that. Okay. Remember that when we do the generate command, that's essentially just creating a template for our deployment. The next thing we're going to do is run this command that's going to create some roles for Selden in oops. Oh, I need to. Sorry, if you logged in or logged out and back in, like I did, you might need to redefine this namespace environment variable. There. And then that will create that role, which we'll need because Selden launches certain things within Kubernetes. And then we will apply the template that we've created. So again, very similar to what we did with Kubeflow itself, except here we're deploying Selden. Hopefully, internet holds out. I don't know why these are particularly slow, maybe because all of us are hitting them at the exact same time. That's probably why. So let's see, hopefully. It's one thing I did not anticipate. If this does crap out, I have a backup with this already installed, so hopefully this works out though for you guys. Yeah, so at this point, what's happening at this point? Someone want to guess? So at this point, we're applying the manifest on Kubernetes, which is also, oh, there we go. Oh. What did I do? Oh, did I mess something up? Oh, when I ran that first command, then yeah. Let me clear that out. Hold on. Let me do let me just, there's a better way to do this, but okay. So if you guys are having the same issue, it's probably because you didn't have the namespace at this point. Oops. Okay. Let's see. Sorry about that. Yeah, and at this point, it's also so it's applying all this stuff on the Kubernetes cluster, and pulling the Docker images. So, oh, that worked. Okay, thanks for correcting me. I should say as well, I forgot to mention this prior. There is no way that I created all of that stuff in that repo without making mistakes, at least typos. So for the first 2 people that fix a typo or code thing or error of any type and PR that into my repo, I have a special prize for you, AI conference prize thing. So extra motivation to do that. And I would really like to give them away because I don't want to carry them on my back. Anyway, okay, so Selden is up. Let's do the, and you should be able to see, this might not be running yet, but you should be able to see the Selden pod. Okay, it is running. The Selden pod running in the cluster. Now let's deploy Pachyderm. So just as a side note, so Selden and Pachyderm and Kubeflow, all of these things are just deployed as applications and definitions on top of Kubernetes. So we're not like, everything at this point is stateless. We could wipe it away and do the same thing and create it again, I guess is what I'm saying. All right, let's do the generate for Pachyderm. Let's make sure I don't make the same mistake that I did before. Let's just try this. Let's see if it craps out. Okay. Is anyone having any success? All right, good so far. Cool. Any questions? Yeah. Just because I wanted to use the latest version. I mean, they fixed some bugs, so. Oh, yeah, so if you logged out of your machine and then logged back in, what you would likely want to do is up here, remember how we created this environmental variable, namespace equals kubeflow. So go ahead and run that again. If you had issues because of that when you tried to deploy Selden, I can come around and help you when we're running or something like that. But that was the fix that I did. Yeah.
You also want to CD into my kubeflow, right?
Yes. Yeah. So the other thing that you want to make sure that when you're running these commands, you're in this directory. It looks like everything worked for Pachyderm, so let's just see. Let's see what's running in our cluster, in our namespace on our cluster. Sweet. So we have Kubeflow running. We have the Selden cluster manager running, and you'll see this pacd. That's the Pachyderm daemon that's running in the cluster. Now, if you do, so paccontrol or paccuddle or packctl is the Pachyderm command line tool. if you do like pack control version, it'll say generating config and all that. But the first time you run it, if you haven't updated yet, the versions of the command line tool and the daemon won't be the same because I updated the command line tool to the latest. Thankfully, Pachyderm makes it pretty easy to update. So all you have to do is just run this pack control deploy local with the namespace command. Let me put that up at the top of the screen. And what will happen is Pachyderm will see that, oh, there's already Pachyderm running in the cluster, but it's not the latest version. I'm going to go ahead and update it to the version that matches this command line tool. That's all that's happening there. And then once that happens, you should see everything running again. You'll see maybe a dashboard deployed for Pachyderm. But now if you do pack control version, not quite running yet. Let's see, maybe. Maybe. Okay. I'm going to, is that working for people? Yes. All right, cool. I don't know why mine is being slow, but I think I just, okay. All right. The expected output would be like this. So I don't know, it could, I'm not sure what's going on there for you guys that are having issues along with me. But I'm going to go ahead and give it a second to run. I'm going to go ahead and log in here just to keep things moving. So you should see something like this when you run pack control version. How many are seeing that? Okay, so maybe most. If you're not, let's see if this one runs again. Oops. Looks like I'm just like really slow on this connection for some reason. If you can just try it again. So if you do deploy local dash name dash namespace kubeflow, it should, let's see. Let's see if it's working. Yeah, I don't know what's going on there. I'm sorry, guys. When stuff is running here in a second or afterwards, I'll try to sort things out for you guys. If you're having issues with that, just look on with a neighbor for now. But you should be seeing this. I guess if we get 80 to 90% of people there, we're doing pretty good. So pack control, again, is the command line tool for Pachyderm. And we can interact with Pachyderm now. So we've deployed kubeflow. Then we've deployed Selden on top of kubeflow, and then Pachyderm on top of kubeflow. Now that we've done that, we have our pipelining, our data versioning, and our serving piece in place, and we can directly interact with those to do the rest of our functionality. Which, if I go back here, remember was this. So the first thing that we're going to do is we need some input data, right? So we need some raw data to drive our training pipeline. We're going to split and pre-process that and then use it for training. So the data set that we're using, it's based on a data set that you can, the full data set's on Kaggle, but I just downsampled a little bit so the training would go faster for the tutorial. And so what we want to do is grab that data and then put it in our version file system. So let's talk about that for a second. So remember that in Kubernetes, there was no concept of like a distributed file system or data versioning changes in our data and all of that. So that's why we introduced Pachyderm. I kind of already told you that it solves that problem. How it solves that problem is Pachyderm, so remember that daemon was running on the server. And we can interact with that daemon to say, hey, create a repository of data in which I'm going to version various pieces of data. Similar to like creating a repository on Git in which you're going to version code. The difference is here, when you tell Pachyderm that it's going to create that metadata associated with that repo, whenever you put data into the system, it's going to content address that data and store it in a hashed form in a backing object store. So every one of these, it's connected to a backing object store. So that could be S3 or GCS or open source versions like Minio or Ceph or Swift or those sorts of things. And so Pachyderm, we talk to Pachyderm, we give Pachyderm our data. It versions it and then stores it in a backing object store. And so this solves our problem for Kubernetes doesn't manage data in a distributed way for this and doesn't version data, so we're going to do that with Pachyderm. So the steps to do that are to create a container for our version data, which we call a data repository, and then we're going to put or commit data into that data repository. Just like you were doing like with Git, you create a Git repository and you put code in it. Here we're creating a data repository and we're putting data into it. Are there questions about that?
Where your repository is stay?
What?
Your repository is stay in the cloud or is?
Yeah, so he asked where the data actually lives. So the data that you are versioning lives in that backing object store. If you were to deploy to AWS, for example, it would probably be best that you use S3, but you could also use an open source solution. If you were on-prem, you might use like Minio or Ceph or Swift or something like that. Some data storage system that has an object storage API, and it doesn't matter which one. Yeah.
So let's say in this example we're using CSV, right? So it's a simple file. Does it get more complicated if you're using a database?
Yeah, so the question was, what if you had a database? So remember that I tried to make this as realistic as possible. Sometimes you're dealing with files. I think people do deal with files in production, but let's say that you wanted to drive this off of a query from a database. So what you would do is you would just create a secret in Kubernetes with the creds for your database. And instead of in this first like split pipeline, instead of just processing a file, you would make a query to your database, pull in that data, and then output it to the version file system. And that way you're always versioning the output of your query. That's how I would recommend it. Other questions? All right. So let's go ahead and remember we need to create the repository, which is just like the place where we're going to store our version data. And then we need to put our data into the repository. So here I can say pack control create repo raw underscore data. And what that's going to do, again, it's going to create a repo called raw data, but it doesn't have any data in it yet. So this would be like creating a repo on GitHub for your code. Yeah. So the question was, would this be similar to other things or other type of feature storage things? Yes and no. So like you could definitely build like a feature selection type of thing out of this, or like a version data set idea out of this. But really all this cares about is that there are the repo entities, and whatever data you put in, it's going to version the state of that per commit. So like you could create a repo for like feature A or data set A or whatever it is, put the data in, then every time you update it or make a change to it, that would automatically be versioned in the system. Like you don't have to create, similar to like Git, you don't have to create another commit ID when you push your changes. You just push your changes, GitHub creates the commit ID, updates master, and then you could go back and look at the version of what it looked like in the past. You could also like tag it or name it certain ways. Yeah.
So when you say versions data and comparing it to Git, how much of that is exposed? Like, can you diff, or do you have like nodes and parents?
Yeah. So the question is basically what are the Git-like semantics that carry over into this context? First, I should clarify, this is not using Git under the hood, mostly because Git is not space efficient for large data. Also, many of the semantics carry through like making commits and having branches and having commit IDs, et cetera, but some of them don't. So like you mentioned diffing, this gets also to like, there is the concept of branches, but if you think about like merging or even looking at diffs, that doesn't really make sense in the context of like larger data sets because no one would be able to, for example, resolve merge conflicts for 2 terabytes of data, right? It's just not humanly feasible. So the branch aspect is really different here in terms of its function, in terms of its purpose, and also like the diffing element. This is really on a file by file level. If you wanted to diff on like a record by record label, you could do that. There's like a internal split functionality in here where we could actually split the records apart automatically and version them separately. By default, it will just diff on each file. Other questions? Okay. So we have our repo. Let's go ahead and put our data in. So I've just uploaded this data to an object store. And what we're going to do is we're going to say, hey, pack control, this raw data repo exists. I want to put a file in there. I'm going to call it by this name, and I want you to pull it from this URL. You might get a warning saying you're pulling from a URL. That's fine. But now when you list your repo, you'll see that there is data in raw data. And you can list file raw data from the master branch. Remember, this is, raw data. Remember, this is like Git-like semantics. So now what we're seeing is this file is versioned in the distributed file system, stored in the object store, and it's in this version collection of data called raw data. Yeah. Yeah, that's a great question. So he asked about retention policy. By default, it will just continually version your data. In some cases, particularly like if you're dealing with private data, or if you have space constraints, you might want to garbage collect things. So there's a garbage collect functionality in Pachyderm. It's not quite where you can have like a time to live, for example, in there. But you can garbage collect things over time. I think their philosophy is that they've taken as like object storage is generally one of the cheaper things that you can have these days. And so by default, they just version everything. Also, I should mention that they're not just creating copies every time. So like if you commit like 1 million images, and then you make another commit and only like 2 images change or update, it won't actually restore everything together. It will just restore the ones that are changing. So there's a lot of kind of sophisticated deduping going on the fly. Say it again. I'm not sure if you, you might need to create it if you do pack control list-repo, you should see raw data. If not, you can go back to the README and see the create repo command. Yeah?
So can you actually on CSV data see new rows which have been added when you create a new version, or
You
not, but can't see if one of the rows changed the data, that you can see, but at least see the new rows that have been added.
Yeah, so this is, the question was, can you actually see, like in a CSV, if you add new rows, see which rows are being added and changed over time? So you can if you utilize their built-in like split functionality. We're not using that here, but what will happen is you would split those, and those would technically be considered different datums in Pachyderm. And then you could see what datums correspond to what commits. In other words, what's being updated, so those records in that case. Also, you can set up like change data processing. So if you only need to see what's new and not everything else, that happens automatically in Pachyderm, at least. You can configure it that way. Yeah. Do you have a question?
I was just thinking through, because you were talking about using object storage, and there's a big difference between buckets and hierarchies and stuff like that.
Yeah, the question was around buckets and if you need hierarchies or directories and that sort of thing. So all of your directory structure and naming is saved as metadata in Pachyderm, and it hashes your files and then just stores those hash files as blobs in the object store. Yeah. Other questions? Yeah.
So Pachyderm's materializing this data somewhere, and it's on my one machine that is one cluster right now, right?
So in this case, like in a normal case, it would be backed in whatever object store that you would specify, S3 or wherever it is. And when we run something here in a second, we haven't quite got there, but when we run a pipeline, Pachyderm will handle the getting of the right data from the object store to the right piece of processing to be processed. Yeah. Other questions? Any luck on that timing out issue from before? Unless I can check mine. No. Okay. Sorry, guys. You'll have to look on with your neighbor for now. Okay. So we have this collection of data. That's our input data. We've put data into that repo. Now what we need to do is we need to create all of the processing pieces that split, pre-process, train, build, and export our model. So getting to the question that was just asked, we need to tell Pachyderm, hey, I want you to create a piece of processing that uses this Docker container to do its processing and processes this data that's in this repository. So the way that we do that is go ahead and get to this directory if you're not there already. And you'll see that there's some JSON files in here. So if we take a look at one of these JSON files, what we'll see is pretty much what I just described. Remember, this is like a declarative framework. So this specification is how we tell Pachyderm how to set up each processing stage. So I'm saying create a pipeline called split. Okay? Use this Docker image to perform that processing. And in that Docker image, run this command, which is just a Python script that we've created and put in our Docker image. And then run that on this input data right here, raw data. Remember, we created that raw data repo? And so here I'm saying, do this processing with this image on this data. I'll get more into this glob and other things a little bit later if we have time. That has to do with the distributed processing piece of things. But this is the basic structure. The other thing that you'll notice, which is related to the question from over here, is I'm saying my input CSV is going to be at /pfs/raw data/ whatever. So when this container comes up, Pachyderm is going to say, oh, you've told me that this container needs to process this data. Remember, we wanted a framework that would get the right data to the right code at the right time. And so Pachyderm will say, oh, I know about that data because I've already created that repo. Let me pull the latest version and shim it into the container to be processed. And where I'm going to shim it in is at /pfs, / the name of your input, in this case, raw data. Like I mentioned, you don't always have to shim in all of your data. There's ways to shim in just the changes. But here we're going to just put in everything because we always want all of our CSV. The other thing to notice is anything I put in /pfs /out, that's a way of telling Pachyderm, hey, this is the output from this stage. Go ahead and version my output in the data repository. So we have input. That's pulled in by Pachyderm into the processing. And then it gathers all of the output and versions that in the version file system as well. Yeah. Yep, definitely. So this is the first stage, but we're going to create all of these next 5 stages, and that part will happen automatically. He asked how to like string these things together. I'll go over that here in a second. Other questions? Yeah. Yeah, great question. So he asked, how configurable is this? And like, for example, if he wanted to split multiple different data sets, would he have to create one of these for each one of them? The answer is no. So what I haven't covered here, and which I'm happy to talk to you more about, is the distributed nature of things. So here, there's this glob of /, which basically means every time I see updates to raw data, I'm going to reprocess everything in there. If I had, for example, /*, that would tell Pachyderm anything under the root of that repo, you can process in isolation. So if you put 10 data sets in there, 10 CSVs, it would process each of them separately using the same command and the same Docker container. And just to kind of illustrate this, there's a lot that, of course, I can't cover in the tutorial. But if you go to Pachyderm and the documentation, down here at the bottom, there's a pipeline specification. And you can see that this is pretty configurable in terms of how data is combined, how it's processed, and resources and all of that stuff. Yeah, so that would really be, remember this is your own code running in here. Here I've just made the code to where I take a sample. But internally you could have in your code any type of sampling you want. But really that would be kind of outside of Pachyderm's domain and more in your code's domain. Yeah. Great question. So the question was how the data is actually mounted in the container, which if you're processing like 200 terabytes of data might be a relevant issue. So there's 3 answers to this actually. By default, Pachyderm will just copy the data into the container, and it will literally just copy the data in, and you can access it just like normal files in the actual container, not a volume.
Okay, you refer to like a docCP, literally copy the file into the
Yeah, there's a binary that runs in parallel with your container that will copy the data over. Now, in some cases, that's not what you want. So what you can also do is expose your data as named pipes to your containers and pipe your data in to your processing. The third way of doing it, which is under current development in the Kubeflow repo, is a way to use a shared persistent volume. So if you wanted to like cache data on a shared volume and then pull from there, that would be a third way, but that's kind of a work in progress.
But you never consider copy the data to the Kubernetes nodes, right? You never.
No, so everything we're showing here is completely stateless. Like if you could pull this cluster completely down, and all of your data would still exist in the object store when you spin things up again. The only thing that would be lost is like there is a caching parameter where you could cache certain amounts of your data on the nodes, and that would be lost, but it would just recache. Okay, yeah. So say it again. Do you have to use Pachyderm for the containers? Yeah, great question. So the question was, would Pachyderm work without a container? So the quick answer is no, in the sense that you need to specify some image. The longer answer, though, is that there is a default image. That default image is Ubuntu. If you don't specify one, it will try to run it in Ubuntu. The other thing that we were talking about in the break is most orgs will not rely on their data scientists to constantly be creating their own images. What you can do is just have a base image, like let's say it's my company / TensorFlow. So they would essentially always specify that. And then there's another type of input that's a Git input. So you could actually just create an input that would pull your code directly out of GitHub, shim it into the base container, and run it from there. Yeah. OK, let's actually run this. You guys probably already are, but I need to catch up. So we have this definition, declarative way of telling Pachyderm how to run this thing. So let's go ahead and provide this to Pachyderm. We can say pack control, create pipeline, split. OK, and it seems like nothing happened. But then if we actually look under the hood, if we get the pods that are in our Kubeflow namespace, what we'll see is that there's a pod initializing. And that pod is pipeline-split. So what happened is Pachyderm said, oh, you've told me that I need to run a pipeline to split this data. I can see I'm currently not running that pipeline, so I'm going to pull the image you told me about and spin up a worker to do this processing. And that's this pipeline split here. The other thing that's going to happen here in a second, as soon as this finishes initializing, I should say too, this doesn't happen like every time you run it. This is like the first time because it's actually pulling the image from the registry. The next thing that's going to happen is that Pachyderm, as soon as this pipeline is up and running, it will see that, oh, and this pipeline is supposed to process the raw data that's in the raw data repo, and that data hasn't been processed yet, so I'm going to spin up a job to process that data with the pipeline that is now running. So as soon as that's running, I can now see if I list job, control list job, Pachyderm automatically spun up a job to do that processing. It processed that data, and not only that, if I look at what repos I have now, I can see that it created another repo called split, the same name as the pipeline, to automatically version the output of that split pipeline. So I didn't have to create that. That happened automatically. And if I look at the files in split, I'll see that I have my test and train set. Questions? OK, yeah. Yeah, that's under the code directory in GitHub in the repo. Over here. If you go to the repo, there's a code directory, and all that code's under here. Yep. Yeah. So I'm not going over this code because this isn't like a Python workshop. But you can take a look at all the code that's running here. Really, I'm just specifying the Docker containers that contain this code. Okay. So now we have this split happening. We need the pre-processing. That's as simple as just saying create pipeline -f preprocess. And I'll see that that also looks similar. It's just running a different script, preprocess data. And here, I'll see again that that pod is initializing here. Might take a second for this one to load because it's a Python container. But as soon as we pull it, the rest of them should be quicker. Are there questions about how things are triggered and that sort of thing? Yeah.
The pipeline split is still running. This is not a Kubernetes job, but it's clean.
Yeah, great question. So his question was basically, we already ran split, right? But the split worker is still a pod running in Kubernetes. So why is that? The reason that is the way it is by default is that Pachyderm is saying, I know that you're going to be updating this data over time. And so by default, I'm going to go ahead and have the workers up that need to do the processing so that they can immediately process things without having to initialize. However, especially if you're doing distributed processing, and let's say we had like 50 split containers or split pods up, we would likely want to scale those down. And so there's a scale down threshold functionality in Pachyderm that will allow you to scale down workers after they're idle for a certain amount of time. Yeah. Other questions? Yeah. Great question. So the question was, if you update the master data set, would it trigger the rest of the things to run? The answer is yes. Actually, down in the exercises, I forget what number it is, I illustrate that. So hopefully if we have time, we'll get to that part. Because really, the setting up the pipeline is one thing. But really, that's kind of like something you shouldn't have to do that often. But updating your data and your code happens pretty frequently. So what will happen is Pachyderm will automatically trigger by default anytime there's a version of data that hasn't been processed by a pipeline that you've told Pachyderm about. That's why these jobs were triggered, because it said, you've told me to process train data or raw data, and I know you haven't yet, so I'm going to go ahead and run this job. If you updated the raw data, then it would say, oh, there's a new version of this that hasn't been processed yet. I'm going to kick off all the things downstream. And this gets back to the dependency question, I think, over here. So you can see that now, when I created preprocess, it automatically took in the output of split. The reason, so the dependency graph in Pachyderm is just built up based on the data. So if you're processing data that was generated by another pipeline, then you're dependent on that pipeline. And when it generates new data on its output, Pachyderm will see, oh, there's new data that's output, that's input to something else. I need to trigger a job downstream. And this is why this is really nice for like failure and that sort of thing, because if you have a really complicated graph, this will mean that if you execute like 7 different stages that successfully complete, and then you fail on stage 8, and then you update your code for stage 8 so that it doesn't fail, you no longer have to rerun all of the first 7 stages. As soon as you update that, it will just automatically update that last stage. OK. Let's see if this actually worked. It's going to be anticlimactic if it didn't. So now we can see again that Pachyderm automatically versioned the output data from that pipeline. And finally, so we've run the pre-processing, we've run the or the splitting and the pre-processing. Now we just need to create the training. So let's go ahead and do that. All right, so you can see that that one came up a lot quicker because it was based on the same Docker image. But it's actually going to run slower. It should still be running because this is the stage that's actually doing our training, so it's actually more compute intensive. While that's running, let's go ahead and get set up for the build and export. So how many here have a Docker Hub account? Okay, not that many. So you have the following options. If you would like to run the rest of the pipeline, like the build and export pieces, create a Docker Hub account right now. So if you just search for Docker Hub, you can create. So Docker Hub is just a public. It's a public registry for Docker images, and you can sign up pretty quick. So if you want to follow along, you can do that. But that doesn't mean, if you don't want to do that, that's fine. You can still run the inference off of the image that I build. So that's up to you guys. What you wouldn't be able to run if you didn't create the Docker Hub account is the building of the Docker image based on our model up to Docker Hub. So that's up to you guys. If you want to follow along with that, remember that our build and export, so the build and export stages, how they're going to work is the build stage is going to utilize a Selden wrapper that's running in Pachyderm to just create the metadata needed to actually build the Docker image for our model inference. So this build output is going to have a bunch of files that include a Docker image and a Python script to actually utilize our model for inference. Similar to like if you were to create a Docker image in SageMaker. Then the export stage is actually going to build that Docker image and push it up to, in this case, Docker Hub, although you could push it to any Docker registry. The kind of hand waving that I'm doing here is I'm kind of trying to imitate what you would likely want to do, but it's probably not feasible for this tutorial. Is this export is actually building the Docker image in Kubernetes. Probably what you would want to do is like have this build trigger maybe a CI/CD build that builds your Docker image in Jenkins or wherever it is, only because here we're using Docker and Docker, which is kind of blasphemous, but it kind of imitates what you might want to do. Happy to talk about that more afterwards if you like. So the build, again, it creates these files that we're going to build into our artifact for inference. The export actually builds that image and pushes it up to Docker Hub, where we're going to pull it down from when we launch our inference servers in the next half hour. Okay. So if you created a Docker Hub account, if you want to do that, what you'll need to do is I've created and this is all specified in the README as well. We go to 1230, not 12, right? Okay, good. I was freaking out there for a second. I have this docker config.yaml. So in Kubernetes, the way that you would expose like credentials, or one way to expose credentials to an application running is to create a Kubernetes secret. And so I've created a template here that you can use. So what you would need to do if you want to run these stages is get your username and password that you created on Docker Hub, and then run something like echo -n, like your username, mine is dwhitenack, and then base 64. And what this is going to do is base 64 encode your username. You would do the same for the password. I'm not going to show you that because I don't want to show you my password, but I could, whatever your password is, you would do that. And then you would copy each of these and replace the respective value in this YAML file. So for example, I would take this and maybe I vim into my Docker config and replace my user like that. And same for my password. I've already done that prior to now because I didn't want to expose my passwords to you guys, although you seem like nice people. But I've just went ahead and done that with this Docker config here. Once you've replaced that username and password, then, and this is all, again, detailed here, you just need to create this secret in Kubernetes. And so I'm going to say kube control create docker config, and you can see a Docker secret was created. And this is just going to allow the pipeline to use my Docker Hub creds to build and push an image up to the Docker Hub registry, where we'll pull it down for the inference servers. I said a lot. What questions are there? Did I lose everyone? Yeah.
Could you install a registry inside Kubernetes?
Say it again?
Could you have a local Kubernetes registry inside the...
Yeah, so the question was, is there a local registry in the Kubernetes cluster? The answer is yes, there is a local registry in the Kubernetes cluster. But oftentimes, or I would pretty much all the time, a company has their own registry outside of whatever Kubernetes cluster they're running. So that might be an ECR, for example, if you're in AWS. So what I'm trying to mimic here is like you have your build pipeline going on here for your model, and you could have from that pipeline a triggered build of a Docker container for inference to whatever registry you're using. Here, that would be Docker Hub. It might be ECR for you guys, or maybe you're hosting your own registry. Yeah?
In today's lab, we don't have to do that in coding if we're doing it as packrat in the accounts.
So you will have to do this if you want to actually run the build and export on your pipeline. But if you want to use the image that I pre-built to launch your inference service, that's fine. Yeah. Other questions? OK. So let's see if our training completed. It's going to be sad if it didn't. OK, success, training. Now if I list file in train on master LC that I have my output model. So my pipeline trained on my training data, which was pre-processed and split, and output this serialized version of my model. Remember, all of these containers of data are version controlled, which means that getting back to the models being versioned, if I output a serialized model or any metadata associated with that model to here, that's automatically version control, so that when I update the model, I'm actually version controlling that model binary. And I could always go back and see what it looked like at any point in time.